Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball, like a marble, across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Powell Mazur and Emil Mottola, in 2006. They tried to think, what else besides black holes could happen when a massive star collapses on itself? That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravastar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, Even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravastar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravastar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravastar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravastar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in spacetime, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity. Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super-powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guest said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, The team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new. A bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things. Really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear. The typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet. An asteroid drifts too close and the black hole seizes it. Gas twists and whirls and gravity starts pulling harder and faster. The accretion disk blazes and spins like a cosmic whirlpool. Radiation bursts out in violent flashes. The poor asteroid gets crushed and torn. Particles stretch into filaments, ripped by tidal forces. And then, in the blink of an eye, the event horizon swallows the asteroid, and it disappears from view. You're standing at the edge of the ultimate cosmic cliff, staring into a black hole. Sounds like instant doom, right? But scientists now say that, in theory, a human could actually explore a black hole and survive. The only thing is that once you go in, there's no coming back. It's a one-way ticket. So, how would it happen? It depends on the type of black hole. The thing is, black holes fall into two camps. There are stellar mass black holes
a few to a few dozen times the mass of the Sun. When a massive star, like 8 times heavier than the Sun, burns through its fuel, it doesn't just fade away. It collapses, rebounds, and explodes in a supernova. What's left behind depends on how massive it was. Medium big ones leave behind a neutron star, an ultra-dense remnant of a star. But if it was 20 times the Sun or more, it collapses all the way down into a stellar mass black hole. Most of the stellar mass black holes we've spotted are the clingy type paired up with stars. Some suck gas from their partner stars and light up in X-rays. We call those X-ray binaries. Thanks to these dramatic duos, we've found around 50 black holes in our galaxy so far. But scientists think there could be up to 100 million lurking quietly in the Milky Way. So yeah, we're surrounded. Next, there are supermassive black holes. These are behemoths chilling in the center of galaxies, millions to billions of solar masses. Almost every big galaxy out there, including our own Milky Way, has a supermassive black hole. Our galaxy's own heavyweight champ is Sagittarius A star. It tips the cosmic scales at about 4 million times the Sun's mass. That sounds huge, but compared to other galaxies, it's kind of a lightweight. Take the black hole in the galaxy Holmberg 15A, for example. It's got at least 40 billion suns worth of mass. To survive the jump into a black hole, you gotta pick this second supermassive one. Jumping into a small black hole is like being dropped into a cosmic blender. The outcome is instant, messy, complete spaghettification. Yep, that's a real science term. It's the process where something falling into a black hole gets pulled so hard by gravity that it's stretched out like spaghetti and then torn apart. But supermassive black holes are enormous, with gravity spread out over millions of miles. Falling into one wouldn't tear you apart immediately. Instead, you'd drift toward the event horizon, the invisible edge where even light can't escape. Picture it like a slow-motion water slide into the unknown. You'd still be fully aware, still intact, watching physics bending in ways you can't imagine. Why does size matter so much? A black hole with the mass of our Sun has an event horizon just under 2 miles wide. Now, remember that supermassive black hole at the center of our Milky Way? It has an event horizon more than 7 million miles wide. That difference matters because the gravitational pull between your head and your toes in a supermassive black hole isn't extreme. You could cross the event horizon without being stretched into a billion pieces. But the terrifying truth is, pass the event horizon and you're never coming back. From the outside, you just vanish. From the inside, time and space twist in ways no human experience could predict. You'd keep falling, conscious, intact, into a region of the universe that is completely, utterly unknown. So yes, humans could, in theory, explore a black hole, but it wouldn't be a thrill ride you'd ever tell anyone about. Once you cross the point of no return, your ultimate adventure will begin. What if you're going to be lost in the black hole forever, floating inside its mind-twisting core? Are you going to end once the black hole ends? Wait, do black holes even end? Decades ago, Stephen Hawking gave us a clue. Using math and physics, he showed that black holes aren't completely eternal. Over insanely long times, way beyond any human timescale, they slowly shrink. They emit a kind of hot radiation, now called Hawking radiation, and lose mass little by little. Eventually, a black hole becomes tiny. But what happens next? That part is still a total mystery. Scientists have some theories, of course. They're not proven because obviously we can't really test them. But they give us a way to guess what might be happening inside a black hole. One of the most developed ideas is called loop quantum gravity. It appeared in the late 1980s, and it tries to explain how space and time behave at the tiniest, craziest scales. According to LQG, something amazing could happen inside a black hole. As the black hole squeezes everything inward, eventually, the weird rules of quantum physics kick in. These rules create a super strong push that can fight back against the collapse. Basically, the black hole could bounce back instead of crushing everything into nothing. After that, space and time start acting normally again. But now the black hole is growing outward instead of shrinking. The coolest thing is that Einstein's theory says this is possible too. Scientists even have a name for it: a white hole. Think of a white hole as a black hole running in reverse. Kind of like tossing a ball. When it falls, it goes down, but when it bounces back up, it follows the same path in reverse. That's basically what a white hole does with space and time. Inside a black hole, everything gets sucked in. Inside a white hole, everything comes out. Nothing can escape a black hole, and nothing can get into a white hole. When a black hole has evaporated most of its mass, shrinking down to something tiny, loop quantum gravity suggests it can turn into a tiny white hole. Quantum effects make these little white holes surprisingly stable, so they could stick around for a while. Scientists sometimes call them remnants, because they're what's left after a black hole fades away. The jump from black to white hole is a sudden change, just like electrons jump between energy levels in an atom. If a spaceship crew watched from afar, a white hole would look almost exactly like a black hole. It has mass, it might spin, and dust and gas might swirl around its edge. But if they kept watching long enough, they'd see the impossible. The white hole would belch with sudden outflow of matter and energy. And then they would know for sure this isn't a black hole anymore. This is a white hole. A black hole has an event horizon, a point of no return. Once you cross it, you're gone. A white hole has the opposite. Its edge is a no-entry zone. Nothing from the outside can ever get in. Inside a white hole, things can come out and mix with the rest of the universe. But since nothing can get in, what's inside is completely cut off from the outside. Nothing that happens out there will ever affect it. But then, how does this filling of the white hole end up there? Could there be a tunnel connecting the black hole that swallows matter and energy with the white hole? And if so, could we leave through the white hole after safely entering the black hole? Sadly, that's very, very unlikely. You can't actually use some kind of bridge or tunnel to move between these holes. If you fall into a black hole, you'll eventually crash into the singularity at its center, even if you survive the initial journey through the event horizon. In any case, so far, these are just speculations, since black holes remain mysterious and unreachable, and we haven't even proven the existence of white holes yet.
Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on. Kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. when the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light-years. It would be a cube about 1,000 light-years on each side. For comparison, our Milky Way alone is 100,000 light-years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate.
NASA has recently revealed some eerie cosmic sounds that go against the popular misconception about the muteness of space. This discovery proves once again that the universe is far from silent. The revelation came from the Perseus galaxy cluster, located 250 million light-years away from Earth. There, NASA uncovered an unworldly howling coming from the supermassive black hole at its center. This discovery isn't super fresh. It was made in 2003. It marked the first time scientists detected an acoustic phenomenon from such a distant source. Sadly, the sound was not something you would be able to hear. Its frequency was just too low for the human ear to register. The lowest pitch the human ear can perceive is 20 Hz, 20 cycles per second. But the sound emitted by the black hole is a B-flat, 57 octaves below middle C, with a frequency of 10 million years. But NASA brought it to the realm of human hearing in 2022, turning that invisible sound into something you could actually experience. It was a breakthrough of cosmic proportions when NASA revealed that sound waves could travel through space, specifically through the medium of the Perseus galaxy cluster. This medium is a hot, dense gas, something far more substantial than the empty vacuum between galaxies. That's how sound waves manage to travel there. Those sound waves produced by the supermassive black hole at the center of Perseus resonate through the hot gas as ripples. It's like how sound travels through water here on Earth. The thing is, space is indeed a vacuum, which means that sound cannot travel through it, in the traditional sense. But the gas surrounding the black hole in Perseus provided the perfect environment for sound to travel. The black hole's powerful jets create ripples, sending vibrations through the gas. And NASA scientists have identified those vibrations as a type of cosmic sound. Previously, it was totally invisible and unhearable. But now, for the first time, astronomers have helped it to take a form humans can hear. To give us a sense of how deep this sound is, NASA raised its pitch by 57 octaves so that it could finally be audible to the human ear. The result is a haunting, bass-heavy hum. It feels as though it is resonating from the very core of space itself. What NASA did is called sonification. This process involves mapping the characteristics of the data to audible sound. As a result, we can experience something that is otherwise beyond our perception. See those brighter areas of the cluster? They produce louder and higher-pitched tones. The sonification of the Perseus black hole isn't just a scientific discovery. It has allowed us to see, or should I say, hear, the universe in a completely different way. NASA has used this technique on several different space objects, including stars, nebulae, and galaxies, giving us a glimpse into the various ways space can sound. One of the coolest NASA's sonifications is Cassiopeia A. It's the remains of a star spotted as a supernova more than 300 years ago. Located around 10,000 light-years away from Earth, this shattered remnant of a once massive star has a neutron star at its core. And it's the youngest neutron star in our galaxy that we know about. To perform the sonification of Cassiopeia A, NASA took the data captured by the Chandra X-ray Observatory and translated it into sound. Starting at the center, a triangle-shaped tone marks the location of the neutron star. Then, the sound spreads outward, which represents the expanding debris field. That's when the pitch rises and the tones become brighter. The sound grows louder and seems to mirror the outbursts of the supernova and the formation of new elements. The Tarantula Nebula, located in the Large Magellanic Cloud, is a hotbed of star formation and one of the most active regions in the universe. Astronomers have been studying this nebula for a long time to learn more about how stars are born and evolve. So, no wonder that NASA scientists have been doing their best to translate the data from the nebula into sound. They've been mapping brightness and pitch to various features in the nebula. So, airy, synthesizer-like tones represent the chaotic and hot gases surrounding the most massive stars. And the cooler gases that are forming new stars have soft, low notes. Piano-like tones correspond to the brightest stars. And the central cluster of stars sounds like a rain stick. Interestingly, NASA's investigation into the sounds of space doesn't just involve cosmic phenomena. It's also based on the experiences of astronauts, and some of them are truly eerie. After all, space exploration is always filled with unexpected surprises, and sometimes those surprises come in the form of strange noises aboard spacecraft. One such incident occurred aboard the International Space Station, when astronaut Butch Wilmore reported hearing a strange noise coming from Boeing's Starliner spacecraft. By that time, this spaceship had been docked at the station for almost 3 months. The Starliner had just completed an 8-day mission that went awry. The technical issues have been plaguing the spacecraft ever since. Wilmore described the sound as a pulsing noise, similar to a sonar ping. It was coming through the spacecraft's speaker system. This strange noise made Wilmore contact NASA's Johnson Space Center in Houston. Of course, Mission Control immediately began investigating. They were able to listen to the audio inside the Starliner. Wilmore even held his microphone up to the speaker so that NASA could hear it more clearly. The people in charge of the investigation finally identified the source of the noise. They announced there was an audio configuration issue with the ISS's complex communication system. The thing is, this system connects numerous spacecraft and modules, and such configurations can sometimes lead to strange noises. NASA reassured everyone that such an issue wasn't really unusual. At the same time, they encourage astronauts to report any unexpected sounds they come across. At the same time, this incident was just another proof of how tricky it is to maintain advanced spacecraft systems in orbit. The Starliner had already faced serious delays and setbacks. And every new issue added extra pressure. Everyone was worried about the spacecraft's safe return to Earth. In any case, it's not the only incident involving eerie space sounds. In 1969, during the Apollo 10 mission, astronauts heard something truly bizarre while orbiting the Moon. Now, Apollo 10 was a dry run for the historic Apollo 11 moon landing. This mission involved astronauts Thomas Stafford, John Young, and Eugene Cernan. They were testing the systems of the lunar module. Everything was going smoothly, and then they started passing behind the Moon. In that region, radio signals from Earth couldn't reach them. At that point, they all started hearing a strange, high-pitched whistling sound. It was coming through their headsets. The origin of this noise baffled the astronauts since it wasn't supposed to exist in the near vacuum of space. At first, they simply joked that it sounded like outer space music. But in reality, the situation was quite unnerving. The astronauts were on the dark side of the Moon, far away from Earth and any help. And now there was also that eerie, mysterious sound they couldn't explain. At the same time, NASA was super worried about astronauts' health and mental condition. So the crew didn't immediately report the noise to Mission Control. But after they returned to Earth, NASA engineers thoroughly investigated the phenomenon. They came to the conclusion that the sound had most likely come from the spacecraft's communications system. The reason could be the unusual circumstances of the mission. After all, the spacecraft was kinda cut off Earth. The Moon was between it and our planet. Still, even after this extensive analysis, the origin and nature of the whistle is still a great mystery for many people. Anyway, all these new discoveries and old cosmic puzzles prove that the universe is far from silent. It hums, roars, whispers, and reveals the mysteries of the cosmos one note at a time. In the future, as our technological abilities continue to evolve, NASA's work with sonification and its study of strange astronaut experiences will likely lead to even more awesome discoveries. And if we listen more closely, we may find that the universe is much more talkative than we think.
Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time, they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us, in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called e-Rosetta, to look for X-rays coming from Ansky. At first, they didn't see any. Then, in February 2024, another group of scientists noticed something new: bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name: quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a super-hot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed a star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see. They're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space, because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large.
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals, and it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar. At least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie. Magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby, gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel. a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Poplavsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Poplavsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang.